Welcome to Spring LIB.
So for this problem, we're going to be utilizing the derivative of inverse trig functions. And this will be useful because we use inverse trig functions in math. They come up. So if we want to find the rate of change or the slope of a tangent line of the graph, then we're going to want to utilize inverse trig function identities and their derivatives. So keep in mind that what we have in this case is the inverse cosine. So y equals the inverse cosine of the inverse sine of t. It could be x, but in this case it's t. That's what we have. Then remember that the derivative of the inverse cosine is negative 1 over the square root of 1 minus x squared, where x is what's inside the parentheses. So now what we'll end up getting is that y prime is equal to negative 1 over the square root of 1 minus sine inverse of t squared. And then since we have to do chain rule here, we're going to be multiplying that by the derivative of what's inside the parentheses, which that's another trig function, inverse trig function. That'll be 1 over the square root of 1 minus t squared, because that's what happens when you take the derivative of the inverse sine of t. Then we can multiply all this together to simplify it further. What we'll end up getting as a result is y prime being equal to negative 1 over the square root of 1, basically everything we see here. The only difference is we can just copy and paste this. The only difference is now we can multiply this bottom portion at the bottom. So we'll have times this right here. And that will be our final answer for the derivative of y.